for that person. So something which tries to mimic human capability is known as AI. So that's the whole picture, but we'll understand in depth what it does and how it's made. So I'll go to the next slide. Okay. First, we'll understand human how a human thinks and he does a job, and how a machine do, and how a robot do, and how an AI do. So humans learns from the past experience and do the things. Like for example, if we're left in a island, we don't know what it is. It's a pristine land, so we just do things which are wrong, and we just learn from that, and then from the experience we are able to adapt in the situation and move on. So that's how a human works. But how a robot works, we give set of instructions to follow that, and we tell them do this if this is the condition, do that if that is the condition. So this or that. So if it's like a if else statement. Okay. So then how an AI works? It also learns from experience. But what is that experience? It doesn't have experience as we humans have. It's something known as data. So for AI, data is what it gets as an experience, and learn from that and solve the problem which we are trying to do. Okay. We'll have a better understanding while we say a lot of other things. Okay. For example, first let's take a small example. If you have stone, paper, scissors, so you have three images which show stone, scissor, and a paper. So you want a computer to learn how a stone looks, how a scissor looks, and how a paper looks. But you don't have it, like you have to code it, hard code it, and make the computer to learn it. So if you only have these three images, it may be you may be able to write a code of 10,000 lines and try to write that this is stone, this is scissor, and this is paper. But if you have different demographics of hands, like people who used to show stone and like having a thumbs up, things like that. So if you have things like that, how will you able to solve this problem? So for this, you have to write thousands of lines of code. This is not optimal way. So for this, we will learn how to do this process. So we'll move on. Okay. So here comes why a mission has to learn. So traditional method, like what I said in the last slide, uh, to to make the computer understand how a stone works, a rock works, or a scissor works, we have to give data and set of rules so that we get the answer. Like if this is a stone, this is a paper, this is a scissor. But how machine learning works is it's like this. So you will have data, but you know the answer. So you know for this data, if this is an image, this is the corresponding hand. So if you show a corresponding stone image, you know that it has to be stone. So if you have a scissor, it should answer like it is a scissor. So like that. So you will give the answers and the data. The machine will generate rules for that. So that's how machine learning works. This is the like overall outcome, or like a vague introduction of machine learning. We'll get in depth into it.
Okay, so let me enhance the point why a machine has to learn actually. So we have a general perception, right? So நம்மலாம் பார்க்கும்போது சோஷியல் மீடியா பார்க்குறோம், லைக் யூடியூப் பார்க்குறோம், வேற ஏதாவது நெட்ஃப்ளிக்ஸ் பார்க்குறோம், அமேசான் பிரைம்ல பார்க்குறோம். அதெல்லாம் லைக் வி லைக் we have the experience of using AI already. So Google search engine, it's a example of AI. Say the right in the presentation you have, right? So the Tesla Autopilot AI. And so why we need AI is something like, so Raghu told the programming point of view, so such that you need not code a lot of lines, you make the machine learn by itself to detect patterns over the data. One more view of why a machine has to learn is, you have a lot of intricate problems in the field of engineering and elsewhere, and a lot of fields actually. So you cannot say, so let me take a problem of protein folding here. So anyone here has a biotechnology or biology background, you may understand what I'm going to say. So there is a problem called protein folding actually. um, what it is actually is, you given a protein sequence, you have to find what the structure of the protein is. So that's the typical way of doing that is they use something called X-ray crystallography. The the mo um, the way it is done, the logistic cost, the experimental cost, the setup cost, everything that is being included in X-ray crystallography is very huge, and the time taking and the time taken to get a structure of protein is also very time taking. In order to like reduce the time, what people in Google has done is they have like uh, used deep learning methods, used machine learning methods to actually get, they just input the sequence of the protein. uh, so if you don't know what protein is like a chain of amino acids. I'm not going to too much in depth, but it's a chain of amino acids. So when you give that sequence, what the model will output is the structure of the protein. Very cool, right? So what it did actually is it reduced the overall protein sequence timing actually. So when you reduce this timing, what advantages it had is, many scientists actually use this model to actually predict the function of when you know the structure of the protein, you can actually predict the function of the protein actually. So when you predict the function of protein, you can predict the overall outcome. So suppose say where protein is used, like where protein are there in our body, like for example say hemoglobin is a protein. So so if you can understand the function, and if you can understand the function of the protein well, you can actually give proper treatment, and you can actually devise new drugs, or maybe you can just understand how the overall body works. So in that way, there are many such problems. Like I said, one example as protein folding, but there are many such problems out there in real world that needs a very integrate that takes very huge time or huge cost to actually implement, which is very easily solved by deep learning methods. So that's one more point of view why a machine has to learn. So, and the next thing is this autopilot. Or the autopilot is a cool feature actually. So you make the car drive by itself. So that seems very cool, right? Like instead of you driving, then you make the car drive by itself. So that's one more way of seeing how AI can be cool like this, and AI can be very helpful in this way. So that's the point here. Next slide. So before going on to before going on to this whole overall presentation, let me brief through the segments in, like the disciplines in artificial intelligence actually. So artificial intelligence is a very broad term. It's a culmination of computer science, it's a combination of philosophy, psychology, a lot more domains actually. But when it comes to the real world picture, what we are seeing, நம்ம என்ன பார்க்கிறோம் actually அப்படின்னா, we are just seeing a very close view of uh, the actual artificial intelligence. Actual artificial intelligence has two main aspects. One is you make the computer think for itself, you make the computer reason for itself. So suppose நம்ம வந்து இப்போ you make it a decision maker. இப்போ suppose say if I want to ask இப்போ நம்ம அலெக்சால இல்லைன்னா say wherever, like say Siri இல்லைன்னா வந்து Google voice input, அதுலலாம் வந்து you ask for what you ask for a question and it replies. So அதே மாதிரி that's just a gist of what the actually is, but the behind the என்ன பின்னாடி என்ன நடக்குது அப்படின்னா, it's a huge process wherein uh, whatever we are going to see in this presentation, அது மட்டும் இல்லாம நிறைய இருக்கு பின்னாடி. ஸோ அது நம்ம இப்போ போறதில்ல, நம்ம வந்து மிஷின் லேர்னிங் அண்ட் டீப் லேர்னிங் மட்டும் தான் இதுல கான்சென்ட்ரேட் பண்ண போறோம். ஸோ மிஷின் லேர்னிங் அண்ட் டீப் லேர்னிங் வரும்போது வாட் வி ஹேவ் இஸ் த சிம்பிளா எக்ஸ்பிளைன் பண்ணோம்னா, we have data, we have the outcomes, or we sometimes we may not have the outcomes. So we have the data, we have the outcomes, and we try to understand the data. So data can be anything, and the data வந்து இமேஜா இருக்கலாம், இல்லைன்னா வந்து ஒரு டெக்ஸ்டா இருக்கலாம், இல்லைன்னா ஒரு பேட்டர்னா இருக்கலாம். சே வெதர் வெதர் டேட்டாவா இருக்கலாம். இன்னைக்கு இந்த நாள் இந்த டெம்பரேச்சர், அடுத்த நாள் வந்து இந்த டெம்பரேச்சர், இன்னொரு நாள் வந்து இந்த டெம்பரேச்சர் அப்படி இருக்கலாம். இல்லைன்னா வந்து ஒரு ஃபார்மிங்ல இப்போ நம்ம நிறைய இதுல வந்து ஃபார்மிங்ஸ்ல வந்து நிறைய டெக்னாலஜி யூஸ் பண்ணாங்க. ஸோ ஃபார்மிங்ல வந்து இன்னைக்கு இந்த நாள் வந்து மாய்ஸ்டரோட கண்டென்ட், சாயில் மாய்ஸ்டரோட கண்டென்ட் வந்து இவ்வளோ இருக்கு, அடுத்த நாள் வந்து இவ்வளோ இருக்கு. ஸோ டைம் சீரீஸாகவும் இருக்கலாம். ஸோ நிறைய டைப்ஸ் ஆஃப் டேட்டா இருக்கு. அந்த நிறைய டைப்ஸ் ஆஃப் டேட்டாவுக்கு நிறைய டைப்ஸ் ஆஃப் மாடல்ஸ் இருக்கு. ஸோ அதுதான் வந்து நம்ம இந்த ப்ரெசன்டேஷன்ல பார்க்க போறோம்.
Okay. We will look into machine learning algorithms by looking into some examples. I won't state like this is the algorithm. I won't explain the math. I will give a problem statement and we will see how to solve that and we'll learn the algorithm behind that or intuitive learning. Okay, let's see. First, so for example, if we have a like house price prediction, that's the first thing we're going to understand. Okay, so if we have three houses, the one which is in the left is a small house which is $70,000, and the one in the right which is big, which is $160,000, and we want to find the price of the house, medium size price of the house. Like how we do that? So normally how we do that? No, so we know the size of the house, so we make this in a graph. So small house and medium house and largest we plot in a graph, and we also know the other prices of the house. Like this is the price of like no much smaller house, like other price, everything we have all the data, but we want to find this house price. So how we do this? So normally from this picture, how we do this means like for example, a small house is 70,000, like big house is like 1,60,000. So from this point of view, how you do that is you draw a line, directly draw a line, because visually you know everything, this line fits perfectly all over this data. And for example, if if you want to find the price of this house, you know you will go straight and you will find the price, something like this. So you know the a medium size house might be like 1,20,000. That's what we do. So this is what we are using machine learning. Like we are intuitively finding the prices of house, like human understanding that. Okay, what if this case is given to a machine and we are trying to make the machine to understand this problem and find the optimal solution for it? So in the or solution, like in the or algorithm pair, it's known as linear regression. So how this works? So for example, if you have 3 points, okay, you want to find the best line for these 3 points. So you will ask the computer to make a line which makes the best fit for these 3 points. So it draws a random line, something like this. Okay. So then what we do, we have to find how good this line is. So or how far away we are from the optimal solution. Okay, so optimal solution na best fit line than optimal solution. So we will see. Okay, first we have to find how good this line is. So how we calculate how good this line is? So we'll calculate error. So how we calculate? So we'll calculate the distance from each point and we add this. So this is an error, and we again move the line. So we move the line and we again calculate the distance. Okay, so and we add the error. So in this case the error got increased. So what it does now, so it will move in a opposite direction where the error is reduced. So next step it will move opposite to the direction it moved and it will calculate the error. Okay, so now it's get calculated. After n number of iterations, it will learn to draw this best fit line. This is what linear regression is. The one which we saw before, like the house, we draw this line. No, so it is statement. The computer was able to do it by knowing the how far away we are from. That's by calculating the error. So this is known as linear regression. Okay, this is one of the important concepts in machine learning, and we will go one by one by understanding, by having a like example. Okay, the next thing. Okay, we saw linear regression for house price. For example, we saw linear regression where x-axis was plotted with the size of the house, and y-axis was plotted with uh, the price. So we splitted that by a line, like we made a best fit line. So what if we have to draw something for three dimension? For example, if you have house price, and if you want to predict the house price, but you know the size of the house and the number of car parkings. So there are two independent variables, x1 and x2, which is the uh, size of the house and the car. So by which you calculate, you will calculate the price. For this, you will not draw a line because it's a 3D plane. Like it's a 3D space. You will draw a plane. So this is known as multilinear regression. So simple terms like so. இதுல இன்னொரு இன்ட்யூட்டிவான அண்டர்ஸ்டாண்டிங் பார்க்கணும்னா லைக் இது பார்க்கலாம். So we are splitting data. That's what we actually do. So இப்போ we take for example carrier. So actually there are lot of words in English. So this is an example. This is known as word embeddings law. So here we have 10,000s of words where each where this 3D space will map each word with other. So if you see something like, okay, okay, we'll take fuel. Okay, so if you take fuel, and the fuel you see gases, gasoline, greenhouse gases, radio, efficiency, vehicle. So fuel is related to all these words. So what we normally do in deep learning is we just split data which has similar meaning. Okay, that's how we do. So this is a small example. So I just want to show this. So I just came there. So these are all the things. Okay, if we go back to that. Okay. We will look into another deep learning, machine learning algorithm by looking into how a student is accepted in a university. So, okay, for example, if you want to get into an university, you have to write a 12th board, and you like not an university. If you want to get into IIT, let's take IIT, you have to have a really good 12th score and also have a good JE score. So these are the two states. So by having these two, you can state that whether this person can get into that university or not. So we'll see three people who and their scores and whether they got accepted or not. So for example, first student, he got 9 in his test, like entrance test, and 8 in his grade. And second student got 3 in his test and 4 in his grade, and he got rejected. And the third student, 7 in his test and 6 in his grade. So here we just want to find how the third person got into this, whether he got into this or not, got into the university or not. For this, what we do, we just draw the student 1 and student 2 points. Okay, so this is student 1, this is student 2. We want to know whether student 3 got in or not. And we also place all the data from the university where the student got accepted. So the green things are the things where the student got accepted, and the red things are the things the student haven't got accepted. So if you want to if you want a mission to, okay, intuitively, how we say that these students got accepted and these students got rejected, how we divide these classes. So we divide this by drawing a line and making this, whether this third, like whether the student 3 got accepted or not, no? We just plot this and find whether the student got accepted or not. Okay, so this is the thing. But intuitively, we did by watching the data. But if you have n dimension of data, like it's not x, y, it's A to Z, like n dimension of factors, like not only grades, not only test score, but also his 10 score, sports activity, how is extracurricular activity. So how you do that? So 2D, it's easy for us to represent, but for multi-dimension, how you do that? It's for human, calculating a 2D is like seeing and splitting it is easy. For multi-dimension data, machines use that easily. Like machines easily solve that. So that's why we go for learning methods. So இதுல வந்து we'll see logistic regression or algorithm, how it's implemented, how we solve this problem. So okay, let's the green things are the students who got accepted, and the red things are the students who got rejected. So we asked the computer to draw a line to split green people who got accepted and people who got rejected. And first, computer draws a random line. Okay. So uh, first, what we do? So we know this: the red point here is not classified properly, and the blue point here is not classified properly. So last time, how we calculated error? So we just add everything and we just give. But here we can't do something like that. So we have to add a weighted error here. So because last time was a continuous statement, like it's a linear regression. Linear regression means it will give a continuous value. For example, we try to predict in a house price. So if X changes, Y also changes. But here we will get a class whether he got selected or not. That's all. So we have to just split it. So how we do it? By giving weights for all the data points. So this is how we give weights. So instead of saying weights, we'll say by we are giving penalty. If this is if this point is falsely, I mean, if this line splits the point, which is wrong, so we'll give a higher penalty. If the line is properly splitting the point, we give a lower penalty. So by this, we'll calculate the error. We'll add all this and we'll calculate the error. And then by iteratively doing this process, we'll come to this state and we'll have a minimum error. Okay. This type of this algorithm is known as gradient descent. I mean, this algorithm, logistic regression, is using gradient descent. That's the thing which calculates the error. Where gradient descent you weighted sum. So it not only see the value of the data, but also the weight it the weight with at which it, like for example, how I say, like so here uh, this is a point which is wrongly classified, and it has a higher dominance over this line, higher dominance, so that this line has to move. So I hope I am clear. Like, okay, I'll get into the next thing. Okay, so this is known as logistic regression algorithm. Okay, third algorithm we'll see by seeing recommending apps. Okay, so for example, let's say you work at Google Play Store and you want to suggest apps for different age groups and gender. So you have three apps. Okay, Pokemon Go, WhatsApp, and Snapchat, and you have data that female I mean, you have like gender and age, like two category, like female of age 15 use Pokemon Go and data like this. So how you suggest the people by having this data. So this can be done by using something like this. Okay, by looking at this, uh, in what factor, like if you want to split the data by age or gender, what is the best thing to do? Like for example, if you split the data by gender, so you have two female who are using WhatsApp, and one of the female is using Pokemon Go. Here, two males are using Pokemon Go and one are using Snapchat. So this is not a pure split. So if you split by gender, but if you split by age, it's clearly splitting. Like age which are less than 15 are using Pokemon Go, and age which are greater than 15 are using other apps. So this is a clear split. So if you split by that, less than 50, it's no, they are using Pokemon Go, and people who are greater than 20 are using other apps. Like and you have to again split the data by gender. So if they are female, they are using WhatsApp, and if it's a male, they are using Snapchat. So this algorithm, this is a machine learning algorithm which use an if else statement where we calculate Gini index and entropy. So these are the two terms. I don't want to go in-depth math into it, but there are two things which we have to calculate at each step of the node. Like at this node, you have to calculate Gini index or entropy, any one, to split the data. Okay, that's how this works. So okay, this is known as decision tree. Okay. Next, we will look into doctors, like something and another algorithm. So, for example, you have a doctor. So, and you say the doctor to split the apple and oranges. Okay, but and you can't and you want to draw a straight line. You don't want to have a curvy line like this, to split the data. So, what you do? So you have to think out of the box, and what he do is he just split the data like this and draw a line. So that's how he split it. This method is known as support vector machine, and we will understand how a machine do this process. So let's take, we have a xy, and you have 4 points. And if you want to split this 4 points, you can draw just a line like this, and you can finish it. But you can do in another step too. So any one of this will help you. Like if you multiply x and y, or if you add x and y, or you take the square of x, one thing will help you. So the thing which is going to help us is we multiply x and y. So if you multiply x and y, you see the points which are red are classified as 0, and the points which are green are classified as 2. So we are splitting data by increasing a dimension. So we will have intuitive understanding of what that is, what I said now. So you plotted this in xy plane, and you want to split this data. So for every x and y, you calculate xy. So for 0, 3, you will have 0. If you multiply it, it will give 0. If 1, 2, it will give 2. If 2, 1, it will give 2. And 3, 0, it will give 0. Something like this. So when again, and you plot this in 3D. So x, y, x, y, and x, y. And you plot this in 3D. And how you can split this? Just by drawing a plane. This is known as kernel trick. This is what a support vector machine do. This is an algorithm known as support vector machine, where a data is splitted by increasing a higher dimension. Okay. Okay. And there is another statement given to you. So you want to choose a pizza shop space. By intuitively, like these are the place where people live. These are the houses where people live. And you want to place three pizza shops in these places, and you want to know where to keep the shops. So by looking at it, you will say like, I want to place it here, place second one here, place third one here. But how how a machine understand to do this process is, first we'll look at this. First, it will randomly place 3 points. Okay, and what it does, it just classify the things which are close to that class. So the blue things are classifying that the houses which are close to that are classified as blue, and the houses which are close to this point is classified as yellow, and and the things which are close to red are classified as this. So what is the other step? So the next thing is the algorithm will try to move to the center of the point it classified like this. And what it against do is it will again calculate the nearby values. So for example, in this space it's blue, but it's near to this yellow star. So it will see this blue star and convert this as yellow. And also here, this blue star, these two dots, red dots, is near to this blue dot, then this red dot. So this is classified this to blue. So at last, by iteratively doing this, and again it will come to the center of this point. So it will come here, and again it will try to classify the points which are near to that as is class. Like this will classify these points as blue, and this will classify these points as red. So again it will make classify these red points as blue, and it goes on. So at last, what we try to do, we made the machine to understand how we do this process. So this kind of thing is known as k-means clustering. Okay. Okay.
You wanted to do PC?
Deep learning. We'll go on to
Okay, so these are machine learning methods basically. So one aspect, one common aspect you see in machine learning is what Raghu has been saying all this time. It is actually you have to you have to go through the parameters by yourself. Say for example, can you go to k-means clustering for 1 second, Raghu? So suppose say you want to do this k-means clustering. Now that you have now you can actually sense from the data, by seeing the data itself, you can sense there are 3 clusters. But what if the cluster is so messy that you cannot differentiate one cluster from the another? And you have to, in this process, what you have to do is you have to actually the initial point here is you have to define how many clusters you want to actually classify this cluster, actually this data points into. So suppose if I only select 2 clusters from it, if I only have say I'm specifying only 2 points to cluster, it will only do that. Or if I want to say 3 points to cluster, it will do that. If I increase that to 4, it will do 4 clusters, but it will not be as accurate as 3 clusters, right? So similar to that, can you go to linear regression for instance? Yeah, similar to here also in linear regression, there is one more thing called, in linear regression itself, you have to suppose say this line actually fits the data. It draws a straight line in between the points so that the error is minimum. But there is also other kind of function. So if you see this line is what equation does it represent? It represents y equal to mx plus c. So there are other equations also. Say there are y equal to say x square, y equal to x cube, or y equal to combination some polynomial, right? So you can have polynomials as features also. So but the problem in machine learning, it's not a problem, but the technique in machine learning is you have to select this function by your own to fit the data. Suppose say in k-means clustering or logistic regression or this linear regression, you have to select the function. You have to select which function can better fit the data. So what you have to do is you have to so yeah, thanks. So so you have to pick the function you want to. So the main thing in machine learning aspect is you have to understand the data by your own. You have to have a better grasp of the data. Suppose say if it comes from medical domain, you have to know the medical domain terms, medical domain knowledge in classifying the machine learning data. Sorry, in gathering insights from the data. Suppose say you are from some other, say operation research, or some say mechanical engineering, you are just trying to pull data from the sensors and doing stuff. So if you want to do that, if with the machine learning methods, you have to have the basic understanding of the domain from which the data comes. So that is one part. So suppose say you don't have any such knowledge, but you have to anyway do the same task that whatever the machine learning does. This is where deep learning comes. So deep learning is something like you don't have to do anything, you don't have to do the feature engineering. So whatever the process I told, the picking the functions or picking this cluster size, everything is called feature engineering. You don't, in deep learning, you don't have to do this in any of such thing. You just have to do one thing, is just to place the number of, you just have to, there are also parameters that are involved, parameters to play with in deep learning also, but the parameters to play with in deep learning is very minimal. And it also is data agnostic as in you need not care about the data so much in deep learning. You just care about how you structure the model, how you structure the neurons, which I'm going to explain in a minute. That takes care of the process of the classification or regression itself. So next slide. So basic, the building blocks of any deep learning network is also called artificial neural networks, also called deep neural networks, is the neuron which I placed over the top left hand corner. So a basic neuron has a combination like this. It's basically a multi-dimensional linear regression function. Basically, that's what it is. So you have something like y equal to mx plus c madri. You have y equal to wx plus wx1 w1 x1 plus w2 x2 plus w3 x3 plus w3 x4 and the mari. So you and the இப்போ x1 x2 x3 எல்லாம் என்னது இட்ஸ் அ பேராமீட்டர். சப்போஸ் இந்த ஹவுசிங் பிரைஸ் இண்டெக்ஸ்ல you classify the houses with the size of the house or the height of the house or the price of the house அந்த மாதிரி. So the x1 x2 x3 are the features that you want to represent. So and the main part of the deep neural networks is you need not have this x1 and x2 planned by yourself. You just have to make sure how many neurons you specify. So after specifying the neurons, say after constructing the network like this in the bottom right corner, you suppose say you have specified the model like this. After specifying the model, what you have to do is there is a process of learning things. So the model, what it does is it just feed forward as in you input the data at the left hand side. The data can be anything. As again, the data can be the house prices itself. Suppose the size of the house itself. So you mention the size of the house in the left hand side. You mention the size of the prices of the house at the right hand side. The prices will be the one variable, right? Here in the diagram, it's two variable. Two neurons are out there. But in the example, in the house price example, there will be one neuron. There will be only one circle at the right hand side. So you and whatever the feature it has to learn, it will learn by itself. That is the main part of the deep neural network. So on the processes, it feed forwards now. So the links here in the diagram is called the weights. The ultimate aim of the training, whatever the training in deep learning terms, is just to assign the weights, assign the value for the weights, assign the correct value of the weight, so that whatever you give at the input, it results in the output. So that's the thing. And the processes, you feed forward the network. That is, the network tries to give some values to the weights. It throws out some value. After that, you with your original data, you compare your results. Then you calculate the error. With the error, what you do is you just back propagate, and the back propagation is done by gradient descent, which is already said actually earlier. So gradient descent is something like is the algorithm that is used to minimize the error, so it actually places the value of weight so that the error is minimized. So that is the basic the basic process of training a neural network. And yeah, so the next slide. So before going to convolutional neural networks, I have to specify there are two main divisions of deep learning itself. So one is called unsupervised, one is called supervised learning, one is called unsupervised. Whatever I said now, whatever the training process I said now is for supervised learning. So for unsupervised, you don't have any output data. That is, say you don't have any y outputs. Say the prices of the house. You will just find the patterns within the data. Say suppose a k-means clustering is one such algorithm. K-means algorithm is something like you are not going to have any outcome of that. You're just going to analyze the data, how the patterns are, how the clusters are. So that is one kind of way you see the deep learning. And so coming to neural networks, coming to convolutional neural networks. So convolutional neural network is something like is mainly used for image oriented data. So suppose say you have we have seen in the initial slide, right? The Autopilot primarily uses convolutional neural network. So the thing is here, can you move to the previous slide? Yeah, so instead of the neurons here, what you will place is, there is, in image processing terms, there is something called a kernel operation. Kernel operation is something like, can you move to the next slide? So kernel, as you see in the right side of the image.
Gokul, 1 second. I will give the access to you. Just share the screen.
Okay.
You just share the screen.
Okay. Are you able to see?
Yeah.
Yeah, yes, sir.
Okay. So instead of the neurons here in the image, what you do is you just have to the convolution unit. What it is being done is it is being replaced by um, the kernel operator. The kernel operator is actually a simple process you uh, wherein you have a kernel, which is the greenish thing out there, and what you input is the image, which is the blue one. So the what it does is it slides through the network, and it just outputs the value of the it outputs the overall result of the output in the next one. So the why we do such thing for images is like, if we do something similar to this one in image, you will have a lot of neurons. If you have a lot of neurons, you have a lot of weights to actually learn. So if you have a lot of weights to actually learn, the learning process itself will dwindle, and you will not get a good outcome. So that is where the thing is. So let's look at the example here. Let's look at a very intuitive example here. So this is, so you can also go through, if you are in laptop, you can also go through this thing, which is called quick draw with Google. So let's try to do this. So yeah, I just have to draw the face here. So suppose say this is, I'm bad at drawing. So yeah, so it found it as a face. Now I have to draw cello. So I don't know what a cello is. Cello is some kind of instrument, but I don't know how to draw it. I guess it's this one. No, this is not cello. Okay. Again, I guess cello is some kind of violin, some resembles a violin thing. So this is watermelon. Yes. It looks as onion. So see, rabbit is very hard to draw. Okay, let me try. Yeah, it's a rabbit. It found it. So school bus. So you got the picture, right? Like I am drawing it straight away here. It detects it says it's what it is. So the basic mechanics behind this one is, I have 1 second. So yeah, see, for each category, they have actually a lot of drawings already in place. So many have, like me, like what I did now, many have actually tried it and actually gave the data to this algorithm actually. So for suitcase, there is one drawing like this. And if you see, a lot of similar drawings have been given. And what the algorithm does behind is, it does the same thing essentially. What is being displayed here, what it does is it gets the input of the image. With the kernel, it convolves the operation of the kernel operation is called convolution. So it does the convolution, gets to the next stage, does this similar kind of convolution, and gets to the end of the network, where you just have to classify which is which. So suppose say I have so there are a lot of classifications here. There are a lot of things to classify. Suppose, so let's say there are like different, let's assume like there are 100 categories here. At the end you will have under categories, each with one. Suppose say the first category is assigned as 1 0 0 0 0 0 until the end. The next category will be assigned as 0 1 0 0 0 0 until the end. So this is the part where we have to specify the things, and the kernel value and the weights and everything will be calculated by the network itself, so that if at the end, if you draw just like what I did earlier, now it will just deduct whether it's a suppose say it's a cello, or it's a basketball, or it's a water. So I guess you got the point. So let's move on to the next one. So this is for the, so water convolution network is for the image data. So the next one is for the time series data. So what is time series data? We all have used this application, like we all have used keyboard in our day-to-day lives. So in the current scenario, what we see is whenever we type something, there will be some suggestions coming up. Suppose say hi, I am. So if I type hi, I am, like suppose so if I type a project engineer many times, what it does is, what the keyboard displays is hi, I am. If I, as soon as I type hi, I am, it will just display project as the next word. As soon as I type click project, it will just display engineer. You might have come across this kind of instances, right? So this is where the sequence prediction comes from. So this is what actually sequence prediction is. Then this is one of the application of time series prediction or time series analysis. So the main the algorithm behind this is called recurrent neural networks. I don't want to go in depth into the algorithm itself, but I just give a gist of what the algorithm is. As similar to convolutional neural networks, you will give data to the network actually. So you will get, let me explain the diagram itself actually. So suppose you have x of t. What it says is you give data x at some time t. The time is the essential part here, so you have to just be cautious about it. So you give a data at time t through a network A. So the network can be anything. It can be a normal neural network. It can be again similar to convolutional neural network, whatever network it can be, and it gives an output h of t. So what a deep learning engineer basically does is he gives h of t, he gives x of t, and he just specifies a neural network out there that can whether he will test the model. Actually he will test the model whether it actually coincides with the data, the input or output. So suppose say x of t can be high, the first x of t can be high. So x of 0 can be high, x of 1 can be im, x of 2 can be a project, x of 3 can be engineer. So for each one, x of 0, for h of 0 should be the next data itself. So h of 0 is what? H of 0 is if it is a I, if it is a high, next thing h of 0 will be I. So if x1 is I, then I am, the next h of 1 will be a project. So we have to structure our data in such a way that we give a model to recurrent neural network. So recurrent neural network is trained in a similar way, like what I said earlier, like this one. But the only key difference is there is something called back propagation through time. So that is the only thing that is different from a conventional network. I need not want to go deep into it, but just to give a gist of what happens in the background. Just wanted to give what happens in the background. So can you explain this, Babu? I'll just turn off my screen. Raghu, you are on. You should.
Okay. Can you hear me now? Yeah. Okay. So you have a network where you want to understand the visual perspective. Like for example, you see this image, you see there is a background, there is hill, there is a character here. So you want the network to understand what are the different things. So what are the different layers, like what are different aspects of the image. So this type of thing can be understand by a network, by a type of network known as transformers, where it's focused on attention. So you give attention to each and every thing, like a background, how a hill looks, how a character looks, and all. Like even it also know how a face, like how a eyes look, how a lips and nose look. So what is the dress, what is hair. We can also make it to understand that too, but we'll have a simple understanding how a background, how a hill and how a character looks. So this can be done by, like, if you want to have, the intuition is like, if you want to split the background, you should have something like this to split this. So but you want to split multiple things, like a character from the background, the sky and the hills. So you have to make the network to understand a different aspect like this. So how you do this? So you will see this by having a text input, like for example, here you see he went to the bank and learned for his empty account, after which he went to the river bank and cried. So here the first bank referred to the empty account. So if the word has to be linked to the empty account linked to the first bank, this bank linked to the river. So you want to make the network to understand that this bank has some relation with this empty account and this bank has some relation with this river. So how do you make this? So how you automatically, without like, machine learning is something where you don't say that you have to see if bank is if a word bank is there, you have to go for accounts, or if bank is there, you have to go for river. So you want to make the network by itself to understand what that is. So here the attention mechanism comes in. So see, so we'll see this attention mechanism by this sentence. When you play the Game of Thrones, this is the sentence. So what you do, you just make this as a vector and you just multiply with some random numbers. You just make a query out of it, and it's also a random matrix. So you do this with three different matrix, and you'll generate query, key, and value. Okay. The next step you do is you will multiply this query and the key, and you will get the attention vector. So we will see what is attention vector. So while training, while training, while training the network will understand the relationship between each two words. So different words. For example, see here. So after training, you see the 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 word game and the word game has high score, which is 98, and the game and play, which are related words, like game and play and all related words, they that also have a highest score. So by doing these kinds of multiplying things and making the network to understand by itself is known as attention mechanism, and this type of network is known as transformers. So that's all for trans. So I don't want to go in depth, and there are a lot of topics inside it where we have to pose uh, position encoding, where for images you have to give position encodings where that the position of the place where the network sees has some relationship with the other place where the network sees. There are things like that for images, but this is the intuitive understanding of what an attention mechanism is and how a transformer works. That's it. Mm.
Yeah. So let's come on to the next type of deep learning model, which is GANs. So GANs, uh, in full form, it's called generative adversarial neural networks. So let me tell the technical phrase first, and let me explain the intuitive picture the next. So the technical phase is something like you have a data. So so this is some kind of what I said is it's so kind of unsupervised learning. So what are we seen till now is called supervised learning. You give data, you give its output, you just try to model the relation. That's what supervised learning is. But this is something like unsupervised learning. So unsupervised uh, aspect of deep learning. So what we do here is we do not specify any output data here. The model just generates data on its own. So to give a picture, you have uh, suppose say let me say to give an intuitive picture, what I have to say is like, suppose say you have sentences like this. So uh, I am 7 years old. I like chocolates, and I used to play, and I like playing football. I like playing video games. So what kind of data that is? What kind of uh, so what kind of pattern does this sentences give? So what you can come out of this? So from this, what you can judge is it's coming from a child of 7 years old. So what you can come up with this? He goes to school every day. He boards bus at 7 p.m. Sorry, 7 a.m. So what he can do is what else he can do? He likes to be with be with his friends. So you can also come up with these kind of statements, right? So uh, GANs is all about this. So given some data, what it does is it finds the pattern of that pattern along the data. So and it also, and what it does is it comes with a new data about the same distribution, like what I said. So what else you can say about a 7 year kid, 7 year old kid? He like to watch Tom and Jerry, or he like to watch, he likes to watch, say what a Ben 10 or something like that. You can come about new sentences like this, right? That's what GAN is. You come up with a new data with the existing data. So and the data is corresponding to the given the similar pattern. So that's what GAN is. So here we have two examples. The model here is what called DALI. It's been done by Open AI. It's a open source. It's been done using OpenAI platform. So what it does is you just give a so this is one more application wherein you give text input and it generates a picture out of it. So that's what you do here. So the model is called DALI. What we see here is we give a text input called a painting of a fox sitting in a field at the sunrise in the style of a cloud monet. So what it does is it generates the data. Generates the data. We are not specifying any data here. The model itself is generating data. So that's the intuitive picture of GANs.
Okay, I will show an example of how, like, there is an example for DALI. Like, we can try it out. Like, I will show you what it is. Like, let's say we will give an input like
let's include the audience. Let the audience say.
Okay, if anyone want to try something, I'll try something first once, and you also say, like, we'll try to look at it. So it takes some time to render and just give the output. So if anyone want to type, you can type in the chat box.
Please unmute and answer, or you can type in the chat box.
So, like, before coming here, like, I try to find an example. I just posted a pineapple monkey where the DALI example tried to draw a monkey with a pineapple. So it's not so accurate. It's not a. It's still training. It's a model which is still on process, which is training, and they are open sources to try it. So see, Fox in space. This is not so realistic, but there are there are models which are photorealistic, such something like Imagine. So you see a trans. Okay, let's see the next example. A marble statue of a pole DJ in front of a marble statue. You just give the statement and it will give output like this. So these are known as generative models. You don't have to specify. You will not have output for these kinds of things. You will just have to feed this, and the network will automatically understand and make a photorealistic image, something like these. Things like this. Okay. Gokul, take on.
Yeah. So the next thing is called reinforcement learning. Again, I'm going to give an intuitive picture, not a math background for this. So what reinforcement learning is, I have to tell you to picture yourself like you're a kid. Now what you will do? Suppose say you do some activity. Uh, suppose say you are telling a story. You are in a storytelling competition, and you're like telling a story to your class teacher or your friends or in your class. So what they'll usually do, usually after telling the story, what usually the teacher does, either they give you marks or give you chocolates, or if it's really bad they will scold you, or they will like your friends may tease you or something like that. So you can actually categorize the results, like they categorize the feedbacks into two things, either a positive feedback or a negative feedback. So reinforcement learning is something like that. Instead of, so whatever we have seen in the neural networks here is, we give input data, we give output data, and we have to model the relation between these two. That is the main crux, right? But in reinforcement learning, you have an agent that learns from the environment and that learns how to behave in an environment. So that is the basic aspect of the reinforcement learning. Suppose say you whatever you see is called a cart pole here. So cart pole is something like you uh, try to balance the stick like this, like this, like this. So I'm not able to balance it right now, but you get the picture, right? So what you make a mission to do this, you make a mission to balance this. How it does is, it tries a lot of iterations. Like what we do, we make mistakes and we learn from it, right? Similarly, it it does one thing, gets the feedback, and the thing is, it increases the positive outcomes. The main aspect of reinforcement is it increases the positive outcome. Like what a child does, to maximize, like say getting chocolate. If a child wants to maximize getting chocolate, he or she will do whatever is necessary to get a chocolate, right? Similar thing. So the mission here will try to balance it. So what as a deep learning engineer, what we do is, we give a positive feedback or a negative feedback. If it doesn't balance, we give say -1. If it balances perfectly, we give +1. So over a period of time, with all this, and whatever the feedback is happening in real time, so over a period of time, what the machine does is based on the previous experiences, it learns on its own and tries to balance the stick. So that's what reinforcement learning is. Just the intuitive picture of reinforcement learning. So the next thing. So yeah, so now we have seen a lot of deep learning models and machine learning models, and so now we are here, like there are actually many actually, but what we discussed here is a general and a great Kickstarter for anyone who wants to get into deep learning. So if you know these things, you will be all right in getting into the deep learning space. And the next one we want to elucidate is something of the deployment. So we have seen the examples and we have seen the models. So how we are going to deploy this, where it's being deployed. So where we are seeing is, suppose say Raghu has shown you DALI. So how it's being implemented, how it's, where it's deployed, in which system it is deployed. So that's what we are going to see here. So there are actually two ways you can see a deployment. One is this way, the one is what is being presented here. So in this you have two categories, which is called edge computing and cloud computing. So many of you might know this already, but I just want to reiterate this. So for example, a great example is what we shown right now. So if you can, you go to the DALI slide.
This one or the
DALI browser. Yeah. Suppose say
DALI
so
or
how, yeah, this one, that one, DALI. Yeah. So this, if you type something in here, it takes a lot of time to render, right? So at the background, how will be implemented is something like you give the input like data in some format, and the machine and the underlying machine will be some kind of a cloud system, that does all its operations, that takes a neural network, computes the values, uh, gives the outputs, again reiterate, trains, and does all the stuffs in the background and just results the output. So that is one way of doing things. The other way is something like you do with the edge. Typically, suppose say a drone, take a drone. Suppose there are already drones that can detect people, that can detect specific people in a crowd actually. So that is one kind of deployment. So can you move to slides? So yeah, so that is one part of view. So but the catch here is not many models that you see here, or maybe it may be deployable in cloud, but not many models will be able, you will be able to deploy that in edge. So when you come to that aspect, next slide. So yeah, when you come to that aspect, there are actually four types of computing platforms. So one is, we all know what a CPU is, so I don't want to get into that. So the other three platforms are like a GPU, FPGA, and ASIC. So I just want to give a brief of what they are, and how you can actually realize some, whatever model you make, how you can realize on those platforms. So so a CPU is typical machine we all have in laptops, we all have in our desktop systems, in office systems and everything, or in servers actually. So basically there are ways to actually implement your model right in the CPU itself. So the next thing is called GPU, which is where Raghu works, uh, uh, where you just deploy your model in GPU. There are platforms and programming frameworks available just to do the same. Uh, and so GPU, what a GPU is, it's basically one more kind of processor, but it has a lots of cores in it, so that you can do a parallel computation in a faster way. So that is what a GPU is. And coming on to FPGA, which is where I work. So FPGA is something like a reconfigurable hardware, wherein you can specify the hardware. You can actually program the hardware as per your need. Suppose say you want to develop a say, I just don't want to go into deep, but suppose say you want to develop a new chip, a new feature in the hardware itself. You can design the hardware right in the field, right at where you work. You can design it, and you can deploy the same in the FPGA chip, and it does the same operation. Suppose for example, say I want we all know this network Ethernet card, right? So suppose say I want to have a high bandwidth Ethernet card with this FPGA chip. I can do this. I can suppose say now my bandwidth is around 10 Mbps. I can increase it to 40 Mbps at the hardware itself. So that is one cool feature of FPGA, and you can deploy the deep learning models in FPGA also. And the A6 is somewhat it's a combination of all these three. ASIC is something like you build your own machine from scratch. For example, there is something called Google Tensor Processing Unit. Can you, Raghu, can you go to browser and just type it? Tensor Processing Unit. Yeah.
Okay. Yes.
Yeah, so this is the chip made by Google for just specifically for machine learning and deep learning purposes. So it does nothing other than deep learning and machine learning. You cannot use like a normal system or whatever we are using in laptops, or you cannot play games in this. So that is specifically designed for machine learning purposes. So that is one view. And yeah, so these are the four ways, four deployment scenarios where you can actually run your model. And yeah, so next slide.
Oh, okay. And I would like to add a point in it. So why this deployment comes? So for example, we work on endoscopy. We both work on endoscopy, but I implement the deep learning model in GPU, and he implement the deep learning model in FPGA. So from my constraint, like what is my constraint is, I have an image. Okay, so endoscopy will have a camera, right? So at each, like for example, for 16 millisecond, I will get an image. So I have do some processing using a deep learning thing, and have to give the output to them for the display. So for example, for example, if I want to detect polyps, so there is something known as polyps. So I'll show what is a polyp. Now, so uh, so it looks like this. So it's like a bowel thing which can grow and cause cancer. So these kind of things, while endoscopists view this, so they sometimes miss this polyp while watching the scenario. So this is really big, but there are scenarios where the polyp will be so small, so the missing rate will be really high. Like we are creating an a, a deep learning thing where it can automatically detect polyps, and the missing rate and making the missing rate to be less, so that the patient can have a better diagnosis. So for these kind of tasks, like I have to process the image instantly, so that the detection is done, so that I will get a warning in the screen that there is a polyp in an image. So for that thing and all, like I have to process the deep learning model really fast. Like really fast means like I will have only 4 milliseconds, 4 milliseconds, like 4 or 5 minutes. That's five, like how you say it's 5 by 1,000 of a second. So I have only have that much amount of time to process this set. So there are a lot of deployment platforms to, like NVIDIA provides some kind of deployment application where you can integrate the model in it and just run in his device. Like, and for example, Gokul talk about cloud devices like TPUs and all. TPU is only for processing deep learning in cloud. For for our purpose, we use something known as Jetson Xavier. It's a NVIDIA device. So so it looks like this. So it's a small system with a CPU and a GPU. It has an inbuilt CPU and GPU. So what we do now, we just get the image, we just process this, and we just output the thing. So running things in this small device is really tough at high FPS. Like high FPS means I have to give the output at every 5 milliseconds. So there are a lot of works which has to be done. So to make that the model was able to run in high throughput. And this is the device is not only factor where we have to look while deploying. We have to look at how big the model is. For example, if we have lot of parameters in the model, like for example, DALI 2. The reason why it took lot of time is that it has billions of parameters to generate this image. It's it's not like thousands or lakhs. It has billions of parameters. So we also have to look in the aspect of how many size of the network to make the model to run for real-time performance. Like there are a lot of factors in it, and there are a lot of optimization techniques like converting floating point weights to intake. There are a lot of deep stuff in it. But to get an intuitive idea, we are saying like the reason why we are not having AI in our day-to-day life is it's so heavy to compute, and it's still in process to create chips for deploying AI. That's what I just want to add it, and Gokul can.
Yeah. So coming to the, so how you actually deploy this deep learning models is you have to code your models in. There are actually many frameworks available for deploying your deploying model. The top three frameworks, like not top three, but predominantly used frameworks are TensorFlow, PyTorch, and 1x. There is something called MXNet. There is something called CNTK. There are many such frameworks, but the predominantly used frameworks are TensorFlow, PyTorch, and 1x. And all these frameworks have the capability of deploying the models in whatever platforms we set, GPU, CPU, cloud, ASICs, FPGAs, and everything. So um, yeah, so just want to illustrate on that. So the next slide.
So we'll look into the current trends in deep learning. Okay, so there is something known as GitHub Copilot. I think most of us have learned this. This is an AI model where, like, it's something which scares people like us, because it it do the process which we are doing now. So you just like see, you just parse the string, like you just give the statement, what are the things you want, and you just give generate, it will automatically generate that function. You don't have to write code, so it automatically do. How this is done is that it is done by GitHub. So GitHub is somewhere we have lot of codes in it, and you have lot of comments in it. So they got all the data from GitHub, and they made a product known as GitHub Copilot, where the use programmer doesn't have to write code. Like in the future, there will be a state where programmer doesn't want to have to write code. It's will be so like he just have to give what he wants. If the computer will understand from that, and it will write a code for us and give. So there are things which makes it scary, and there are things which are really fascinating to see, and the other things like image in which we saw, and another thing. So in nowadays, like AI is implemented in cybersecurity. For example, cybersecurity is something like you see a lot of frauds, and like there are not a lot of network traffics, like lot of payments which has been done at instance. So AI has the capability, like human doesn't have the capability to watch all the things at once, but AI has the capability to watch all the things at instance and identify a pattern, and giving an alert if that pattern may had caused uh, any problem in the uh, past, and just alerting the people that there might be something which is going to happen for you or something like that. So AI is actually the next, I mean, it's the AI which are used in cybersecurity is one of the uh, biggest thing, and it has been done by IBM, and it's known as Watson. And the other thing we'll look at, okay. Okay. NVIDIA has a kind of AI for predicting um, climatic conditions. So, uh, so we see forecast like we people like we see that people are stating that in the next 100 years, the Earth will be like this, the Earth will be like that. So these are the things which are stated by the scientists by using AI and machine learning, by watching the past data and by predicting how the future will be. So they have years of data, like hundreds of years of data, and they just use the data to predict the future. So here, for example, if you see in this video, we'll have one slide where so we'll have one slide where
efficiently on GPU accelerators. They're composed.
okay. Hmm. So okay, The thing is, like, you give all the data, like all the weather condition data. For example, you have something like this. So you at this time step, at this time period, and you feed all the other things, like this is the temperature at this point, and this is the like this is the humidity, everything you give. You see that there is a cyclone formed at this portion. So if you have all the data and training the model to understand how this condition is, and they are doing like to predict the climatic condition, how it's getting changed by seeing the past data. They are just predicting there might be a cyclone. For example, Google weather, how it gives an alert like 3 p.m. there might be a rain. So by seeing the past data, they just analyze all the patterns and give that there might be a rain. So it's not, it doesn't say that there will be rain. So it always states that there might be, because deep learning, AI, ML, everything is just a probability. So there might be a chance. So we can't, so using deep AI and deep learning, you can't say this is going to happen definitely. That's you can't be so sure. There is a probability, but the probability can be really high, like 99% it can happen. It depends on the score it gives. So that's how like in weather forecasting AI use. And okay, and another example, okay, Boston Dynamics. So Gokul talked about balancing a stick. So Boston Dynamics is a really great company where they develop robots like this, where the robots like if you see the earlier version of Boston Dynamics robot, it was like it was unable to stand itself. So by means of reinforcement learning, it was able to understand how to run, and now it started to dance, it started to do parkour, things like this. So there are these are the recent trends in the in AI, and we'll also look in some other. Okay, Zoox. So Zoox is one of the company, one of the most like advanced autonomous vehicle company, where it's by Amazon actually. Actually, it has full autonomy, level 4 autonomy. So for autonomous vehicle, there are levels like level 0 to level 5. So level 4 autonomy is somewhere you don't have like level 5 autonomy. I will talk about level 5 first. So level 5 autonomy is where you can drive you can put the car in any situation, any place, like any, like you can also put the car in Mars and Moon. It can drive on its own. But level 4 is where you can put the car in some place like city, village or something. It can drive in that place. So as per now, we have level 4 autonomy, which has been done by Zoox. So this is the one thing which is really fascinating. Like they started using taxis, like giving taxis in California state, things like that, and other thing. So okay. So AI also have implemented in gaming industry. Okay, I'll show how it is done. So in gaming industry, like the GPU has to process the information which has been displayed in our screen. So here the GPU, if it's a low power GPU, low end GPU, it's not a high power GPU, means it won't be able to process the image as quick as possible. Like if you are playing a 60 FPS game, it won't be able to process at 60 FPS. It will be only able to process at only at 30 FPS. So what they're doing is they are processing low quality images and making this image into high resolution, something like this. Like you can, okay, something like this. This is known as super resolution. So actually, we also use this in our endoscopy, since our endoscopy camera is just 400 cross 400. It's just like a ballpoint pin tip. It's that small. It's not equivalent to your phone camera or something. It's so small because it has to go inside our uh, like trunk. So so this type of super resolution thing is also done in gaming industry, but also done in medical industry, where we want to enhance the image to view it. So I think these are the recent trends, and I think that's all for today. And I would like to have a Q&A if anyone have any questions.
So anybody have any question, you can unmute and ask. Okay, I have a doubt. So இப்போ நீங்க வந்து அந்த ஒரு வெப்சைட் காட்டுனீங்கல, like monkey with pineapple and
Yeah.
dinos are playing and all.
Mm.
So அதுல வந்து will they have a specified keywords? Only these keywords will work அந்த மாதிரி?
No, it
No,
doesn't
no,
have
it
any
can,
it can be anything.
you can specify any sort of sentence, phrase, actually.
Oh, okay, fine.
I will share this PPT. You can also try this one. Actually,
Yeah,
this
sure.
image N is actually not an open source thing.
Okay.
Currently, they are accepting tweets